off we go. All right, and again, thanks everyone to join this webinar. So it's a second webinar we're running during December. So the last one, or the latest one on last Tuesday was sort of overview webinar when we touched on different initiatives that you can run. So it's cloud native and how Siebel, modernizing Siebel to allow us to run Siebel in the cloud native way on Kubernetes. Then the second initiative was the introduction of Kafka, so some good stuff Siebel done with that, but mainly what kind of use cases we can have within Siebel environment to implement some cool stuff with that. And finally, it's about Siebel UX and how we are progressing with the offering we have from the Dia-Portriga side and how different partners and clients can use it. Okay, my equipment falling a little bit here. Sorry about that. Okay, and so and then we have these 3 dedicated seminars to each of the initiatives. So today is the first one about the cloud native architecture, and then on Wednesday, same time, we have webinar about Nexus Phase, Nexus Ops, and Nexus Sprints, like methodology, how to approach Siebel transformation. And then just before to finish off the week on Friday, we have something about Kafka and show you how we done some stuff with Kafka at Konecranes, and again, maybe to show like some interesting cases, how you can use Kafka in a bit different way than just message queue. Okay, and again, with that, I will start with the slides. So share screen. Okay, so today's topic is introduction to cloud native architecture. And Alex participated in the first webinar, but not the rest of the people. So I will recap quite quickly about that, because the world we're living in, Oracle Open World, sort of major Oracle event when different clients, partners coming together and Oracle explaining them everything they are doing and what they're going to do. It was canceled. So we had this Siebel Virtual Summit back in September. Among other things, Oracle had a session or 2 on this stuff that they're doing, which is cloud native architecture. So here is the slide from George Jacob presentation, how we used to have, or how we have now this kind of Siebel setup, pretty much familiar to us, and then how it's going to change with this cloud native infrastructure or architecture way. Then there was a talk by Chandan. He's like one of the leading engineers on the team at Oracle. And basically during last year, he was busy with this cloud native thing. The region of this cloud native initiative at Oracle is such that Oracle as a company decided to put together a new product, which they call Digital Experience for Communication, which is, again, first targeted at telecom clients. So they build it in a way that all the UI is created with this fancy Redwood design system that they have. And then through some kind of middle layer, they are also talking to different backend systems. Basically, previous acquisitions Oracle did in the telecommunication space, maybe billing system, provisioning system, and of course, Siebel plays a role in it as well. Oracle itself is launching a new product, which under the hood is using Siebel. And for us as a Siebel customers, that's great because this is like another reason for Oracle to keep investing in Siebel and making it better. To ensure that Oracle itself is able to run Siebel on the massive scale, to ensure that they can efficiently use cloud resources over there at Oracle, so that they can make sure that Siebel is up a lot of the time, so that it's easy to monitor and manage Siebel itself, and also have these frequent releases in a safe and cost-effective way. So they decided to do something about it. And basically what they've done is they made Siebel cloud native. And with that, this is what we're going to explore during today's sessions in kind of more details, like what is this cloud native and how does it work? And basically, this is kind of the picture that Chandan shown in his slides. Like, okay, here is Siebel, it runs in Kubernetes cluster, and there is a whole bunch of unfamiliar tool to Siebel developer or Siebel administrator, which are doing something. And they're basically doing a few things here. Then they also showed that it's not just sort of cheap talk that they're doing, but they have something tangible in-house already available. So, and then they kind of run a few demos, how you create environment from scratch, how do you do auto-scaling, how do you do canary release. Alexander will explain what it is, and some A/B testing. And the last demo was more about Kafka integration, so we will not do it today. And actually, we will not do any of these demos today because effectively we don't have Siebel Cloud Native environment ourselves yet. So it is going to be available sometimes next year. So what I know is that this digital experience for communication, at least under the safe harbor statement by Oracle, meaning that we can say whatever we want to, and you can make any purchasing decision. So under this statement, they say that they will probably have the first release of the digital experience communication either in December or January or February next year. So it's very close already. And from a Siebel point of view, it works fine. You can kind of also listen more about how Oracle presented and Oracle giving all these demos in these two sessions. So if you had with this short link to one of the Oracle pages, you will be navigated to this virtual summit site. And then it will position you directly on the weeks, from 22 to 25th of September, with the sessions which took place during this week. And then there you will be able to see these two presentations. So one is Cloud Native Architecture, where Chandan explained kind of the basics. And in the second session, they had all these demos done. Maybe a couple of words about Cloud Native. When we first ourselves heard about Cloud Native, we kind of started not to Google it, but was like, okay, another buzzword Oracle is using. And okay, we heard like Siebel as a microservice, cloud. I mean, everybody's talking about it, but is there any kind of something substantial and solid behind that? And maybe the first point that we all should know is that cloud native is not like abstract thing or just buzzword. It's actually a foundation, cloud native computing foundation, which is driving adoption of building and running application in this modern way, so that it is kind of a bit in the microservice way, and it's cloud agnostic or platform agnostic. So it provides ability to scale and ability to monitor. And there is actually a whole bunch both of different tools which are available, which fulfill different roles, and we'll have like another slide on that a bit later. But also there are kind of big companies which participate there, and Oracle is one of the players in this domain. So basically, it is an organization which is trying to put some guidances, like how you should build applications in that way, which is modern and scalable and stuff. And some products go through kind of certification or review by foundation, and some are just like not there yet. At the core, we have Kubernetes and a whole bunch of backing services which provide such things as observability, scalability, service mesh deployments. Again, Alex is going to dive on these topics in the details in 5 minutes. Then, even though it says cloud native architecture, but it can operate both on the public clouds, but also on-prem. So let's say if, as some of you guys doing, putting OpenShift platform in the local or your company data center or your client data center, then you can sort of replicate these cloud capabilities which are needed to run application in the cloud native way. You don't need to move your Siebel to clouds, to Azure or Amazon or Google or Oracle Cloud. It's fine to stay on premise if you choose so. And effectively, what happens is that Siebel services are running as any other service that you have in this Kubernetes cluster. From a technical perspective, following the talk we had with Chandan last week, that Siebel was engineered 25 years ago. Okay, so maybe a bit more. So they had like first release 25 years ago. From the very beginning, it was built in pretty modular structure. So we have all these different components running on object managers. And basically, through Siebel configuration or server configuration, we can say, how many EIE components we could have, how many object managers to handle partner portal we should have, how many for call center, et cetera, et cetera. So Siebel itself is pretty modular. And basically what Oracle had to do is just to change the wiring of that so that all the management of the different Siebel components is taking not in the way how it used to be for like many, many years, of course, with some introduction of zookeepers and upgrading infrastructure a little bit. But pretty much it stayed there as it is. So like all the components dedicated to particular jobs and, which were communicating to each other, and we could ability to manage them manual. And basically what they've done now is that they put all the different components as independent services. And then, if two components need each other to effectively provide certain service, they can, be put together in one pod. This is again what Alex is going to be. From technical point of view, all the rewiring was done, but Siebel itself stayed the same at the core, meaning that all the business logic that you have done, it's still there. All the integration which you build for your clients, it remains in Siebel. And effectively, cloud native architecture is just an additional deployment option. So you may choose to run it in the way how you do it now, or you can do it in a way how Oracle is doing that. A good thing about that is also that Oracle itself is testing this architecture first So they will be enjoying this early adopter life initially. So figuring out what is not working, fixing it, etc., etc., so that we don't need to do it ourselves. And I think it's pretty cool stuff that Oracle starts to eat its own dog food totally. Again, as I told, that it's coming sometimes in 2021, so next year. Upgrade to the latest version is required. So whenever at whatever version Oracle is going to release it. So is it going to be 21.3, 4, 5, 6? So to adopt cloud native architecture, you would have to upgrade to this version. The benefit, first we are talking about this high availability and scalability of Siebel, and cloud native tools, they provide this or simplify this or improve this capability. We're talking also about standardization and simplifying Siebel operations. I would put emphasis maybe on standardizing from the enterprise point of view. So basically, if you have already organization which is running Kubernetes, and then all the tools you saw on the Chandan's slides, they look familiar to them. Now, maybe not for Siebel administrator, but like standard DevOps people, they are very familiar and they know how to work with those. And basically now, as a Siebel professionals, we'll have a chance to learn all this cloud native stuff, so that we have not just Siebel skill, but something else which is marketable in the job market. But also, if we have difficulties to hire new Siebel administrator, then traditional DevOps people who know how to run Kubernetes, they will be able to manage Siebel as well. And of course, we also want to do more frequent releases, and we want to do them with less risk, so that something is going wrong, and also with less cost, because quite often the deployment is something where many people need to be involved, and some manual activities are involved, and we all should stay alert. And if we have to roll back, then it's even worse. But this cloud native stuff should sort of simplify it and make safer. With that, I finish my part, and maybe Alex, you take from here.
Hello, everyone. My name is Alexander, as Juris mentioned, and I'm now driving this cloud native initiative inside our Idea Puerto Rico organization. And so with the first words, let me a little bit dive into what Kubernetes is, what is cloud native and what is not cloud native. And then I will show some real case demo of how applications can be deployed inside Kubernetes, how they can be observed, managed, maintained, and scaled out, scaled in, and so on. Let me start with Kubernetes cluster itself. So if you've been on the first webinar that Juris was hosting last week, I already did some explanation, but let me recap about that. So Kubernetes is an open source container orchestration platform, and its main point of using that is that it automates many of the usual application lifecycle processes like deployment, managing application, monitoring application, and scale it out, scale in. So here I would remark once again that it's all about containerized applications. So Kubernetes is a platform for hosting these containers. They can be Docker containers, or it can be containerd containers. So it's just another container provider. In other words, Kubernetes can cluster together different hosts, both on-premise, public, private, and for that, Kubernetes makes it ideal for hosting cloud-native applications. And precising on what really these cloud-native applications are, these are just a collection of small and independent services, and the main idea about them is that they should be loosely coupled and have their own release cycle, and thus it enables business to release pretty fast in small iterations and make these releases fearless and safe enough. Also to build them in a way so that your application would be scalable, highly available, and fault tolerant, of course, by its best. Here, to navigate through how to build cloud native applications, the 12-factor app methodology might help you. Let me a little bit go through it. I will also put these links in the chat later. A few years ago, there appeared so-called 12-factor app architecture methodology, which says what principles should be observed inside your applications, like that every application should have its own code repository, no shared repositories, all your dependencies, both code dependencies and operating system dependencies, should be isolated from your application, that all your configurations should store in environments, not to be inside your application, that all the backend services should be abstracted away as attached resources, like you should have different stages for building, releasing, and running your applications and so on. So you can take a look at like offline. And now also, if we monitor how this idea is improving with time, we can find out that actually there are a few missing factors that are now added to this 12 one. And now in total, by some resources, it's 17, by some resources, it's 19. But the main idea of these new added ones are that your application should be observable, they should be schedulable. Schedulable is, I think it's more or less Kubernetes term, so I will precise here that your application should define how much resources it needs to be running, and then your orchestration platform will take care of where to put your application based on free resources on servers and how much your application needs them. Also, that your application should be upgradable. It should use the least privilege possible. That means that your application should never run as root on your servers, for example. They should be auditable, securable, measurable. And all of that together, if you obey all of these rules, your application magically becomes a cloud native one. So this is like, if to cut long story short.
Yeah, Alex, is it so that if I have application which does not comply with all these factors, 12 or 15 or 17 or 19, whatever, that I still can use Kubernetes, right?
Yes, of course. Kubernetes is just an orchestration platform where you can put any container. It might be have even hard-coded configs and so on. So it doesn't restrict you with that. But if you want to have highly available, secure, and maintainable infrastructure, of course, it's better to obey all of these rules. So that's why these 12, or now it's up to 19 factors, they ideally should be at least consideration.
And the way how I understand it now, that as you know, that you can now run Siebel on Kubernetes as well. And some companies like Reply is doing it for their clients as well. With this change, with this cloud native architecture, Siebel makes Siebel itself cloud native. So they went through all these requirements through the sort of the list what cloud native architecture should do, and basically provide an interface or capability within Siebel that Siebel is observable, etc., so that it kind of works well within this whole infrastructure of different services around Kubernetes.
Also, we will now dive a little bit deeper inside how to build cloud native architecture inside your Kubernetes cluster, because Kubernetes cluster is just some platform that allows you to run containers. In Kubernetes terms, they are called as pods. And each pod can run from 1 to any number of containers inside that. But ideally, for each pod, you should have one container. And then some services which helps you to load balance the network traffic towards your pod. And here, let me immediately showcase some application that I will use for today's demo. Let me also show you the high-level diagram of what we have now inside our Kubernetes cluster deployed, so that when I will touch different components, we'll get idea where it's in the whole landscape. So we have some Salesforce service. I don't know, is it legal on Siebel demo to say this word, Salesforce?
Yes, it is.
Okay, yeah, and then inside our Kubernetes, we have Kafka installed. And when I do any change in Salesforce on accounts or contact level, what happens? The data from Salesforce is taken by Salesforce source connector, which is deployed inside Kubernetes. Then it sends this information inside Kafka topic. Then another connector picks this data from Kafka topic and put in some external system database. Then we have another application which connects to this database and show it in UI way. And then if some changes happen in this external system, these changes are also transported inside Kafka topic. And then with the help of some intermediate container, these changes are pushed back into Salesforce. So these are here, I have this external application. Here, for example, I have Salesforce instance. And so the main idea of these applications is to have a perfect sync between Salesforce and my custom application. And for example, let me do some update on account level. As you see here, account name is account 1.6. Here is also 1.6. Let me change it to 1.7. I'm clicking save, and these changes are immediately sent through the Kafka, through different connectors inside our custom applications. If we go back to presentations, so as I've mentioned, inside Kubernetes cluster, we have these so-called pods, which are our containers. We can also check it on Kubernetes level. So here we have our 5 of our containers, one source Salesforce source connector, which is components that's picking changes from Salesforce and send them into Kafka. We have sync connector, which takes these changes from Kafka and puts them inside external system database. We have application backend, which is the backend for this UI that I have showed to you, and which is connected to this external database. We have front-end application, which connects to this backend and which looks like this. And we have also some components called sync output connector that streams all these changes back inside Salesforce from our external application. So this is just like high-level diagram of what I will be using for this demo later. Here is like small introduction of Kubernetes cluster and how it works. And of course, if you manage your cluster inside your company, you will get into the situation how to manage your cluster always up to date, how to get all the history of what has been changed inside your cluster. And as well, of course, we should always be prepared for any kinds of disaster recovery or for infrastructure migration if we are going to, at some point of time, migrate from for example, on-premise infrastructure to cloud or from one cloud provider to another. Here appears the one panel which going on top of this Kubernetes and will make all of our infrastructure more in cloud native way. So, and once again, I will repeat here that cloud native is just some principles that will help you to easily manage all your infrastructure. So the first thing to cover is how we and Cloud Native Foundation recommend of how to do the changes inside your Kubernetes cluster and how to deploy applications there. Here we will talk about the GitOps approach, which actually means that all your changes to your cluster are immutable. That means that you never change your cluster in an imperative way. You just in some declarative way precise what you want to be inside your Kubernetes cluster. And also that means that all your configurations will be stored in some version control system like Git. Immediately you will get all the version history of changes that were done inside your clusters. And also it will make sure that your cluster is always in sync with configurations that are stored inside Git. As well, it will help you in case of disaster recovery or in case of migration, because you will have just one single Git repository. And then with the help of a project called Argo, you will be able to immediately synchronize all your Git repository with some new Kubernetes cluster from zero. And so that means that all your infrastructure can be set up from zero just in like few seconds or minutes, depending on how much time it takes to deploy, comparing with regular approach when in case of disaster recovery, sometimes it takes, I don't know, hours or even days to recover. I think this is really cool feature. And let us, for example, deploy something new to our Kubernetes cluster with the help of this GitOps approach. So how it works. We have some Git repository. Here it is. It looks like this, just a bunch of YAML files. And inside these files, we are just putting some configurations for our Kubernetes cluster. And as we're showing here right now inside our Kubernetes cluster, there are deployed 5 different components, and we can find configurations for all of them storing here. So one of them is like backend container deployment, front-end container deployment, and for example, I want to release a new version of our front-end, and in our new version, I would like to change, for example, the color of our header. So what I do, I have already prepared for you some script that states that, okay, I want to deploy the version 2 of our streaming app frontend. I'm providing the Docker container name, what I want to deploy. I'm providing some additional configurations because based on a 12-factor app, all configuration should be stored outside, some secrets how to pull that image from private repository. And then everything I do, I'm just pushing these changes into our Git repository. Everything gets pushed. And now let me go to Argo. And Argo in this landscape is the tool that helps to synchronize this Git repository with your Kubernetes cluster. Here we can see everything that's right now deployed inside our Kubernetes cluster. And we can see that there are actually quite a lot of components that we will touch like in 5 minutes, I suppose, like Grafana, Istio, Jaguar, Elasticsearch, and so on. But we are right now interested in this thing, which actually is the application which will deploy all the related containers for this application that I have shown to you. And we can see that, yeah, like streaming, application back, front, sync connector, output connector, they are healthy and in sync, but we have some new resource that is out of sync. We can always check what's new there, and we can just run sync, wait for a few moments, and we see that this resource is now releasing inside our Kubernetes cluster, and everything is done. It has deployed the replica set and pod for our front secondary application. And let me also check that Argo is not lying to us. Yeah, we see that next to our old front-end version, we have also deployed the secondary version of our front-end. We will not see our changes here right now. We still see that had the result of blue color, and why I explained a little bit later, because everything is working perfectly right now. So just because we have deployed the new version of application, it doesn't necessarily mean that this new version will be immediately shown here, but this we will cover just in a few moments. So these are what I wanted to say about how we propose with rollouts of our applications inside cluster. The next topic to cover is that, again, according to cloud native architecture, all our infrastructure should be really observable. And that means that we should, in some standardized way, get immediately and in real time how our applications are behaving, get their monitoring results, some metrics to check their performance, either they are up and down. And for example, when we have some service mesh of, I don't know, 1,000 services like Netflix is holding or some other big companies, we should see in a pretty fast way, we should be able to see where exactly our request chain is stopping, for example. And here, according to Cloud Native Foundation, they are incubating or releasing a lot of different cool tools for observing all your Kubernetes cluster. And here we have Jaguar for tracing. We have Prometheus and Grafana for monitoring your applications in real time. Also Fluentd, Elasticsearch, and Kibana for getting your application logs. All of them together looks in the following way. So if we are talking about Prometheus, it works in a way that, again, according to some of the new factors about cloud native application, your application should be measurable. And that means that each of your cloud native application should expose some metric endpoints, which will in real time tell what your application is doing, how many requests it has received, how many, I don't know, accounts it has processed, what resources it's using, and so on. And then we have Prometheus, which is scraping these metrics endpoints from time to time and putting them into its time series database and provides you the possibility to overlook all of your infrastructure in real time. So here in Prometheus, we can always see all the targets from where it's getting the metrics and monitoring that. And then we can, at any point of time, we can check like what kind of metrics are available inside your Kubernetes cluster. Most of them are getting just out of the box, so you don't need to do anything to configure them. Like, for example, I want to check how many requests I'm getting in some of my Kubernetes application, and I haven't done anything for that because some of the tools that I'm using inside my Kubernetes cluster, they are doing that for me. So they are counting how many requests I have received for this or that application. Of course, this data is pretty hard to translate and to use, and that's why we have Grafana, which will build beautiful graphs on top of that metrics that Prometheus has collected for us. And we can, for example, see how many resources are available in this or that application, like CPU, memory usage, and so on, inside of different namespaces with different application spots and other stuff. So you can, as you see, these graphs, they are real time, and I will immediately see if some of my application, for example, will start to use more CPU or memory than needed. And of course, here are more technical information, but of course, you might be also interested in some business logic, like in case of our streaming of Salesforce changes, how many accounts has processed one of the services, for example, and here we can expose our personal metrics and also show them inside Grafana. For example, here we see that at 6:30, one account was processed by source connector, the same account was processed by sync connector, and then this account was received inside our application. No accounts were sent from our application, but if I do some change here, just in a couple of seconds, because it's not completely real time, you get like around 30 seconds latency, but this latency can be configured through your scraping configuration. But yeah, here we see that at 6:40 one account was sent from our application back to Salesforce. Also, we can see some amount of requests done and all other stuff. So that's about Prometheus and Grafana. We have also Jagger, which helps you to understand what applications were involved in this or that process. For example, here we just see some Prometheus doing this scraping, and it goes directly to some of our backend applications. But of course, we can try to get some more complex results. Okay, we don't have too much traces information right now here, just because we haven't executed that much traffic for the time. But this is just to get some overlook. And of course, we have Fluentd, which can be installed inside your Kubernetes cluster to collect logs from all of your applications. And that means that you shouldn't configure logging for each application separately. You just do a regular logouts inside your app, and then Fluentd just picks the Docker logs and forwards them together with some additional information into an Elasticsearch. And then with the help of Kibana, you can check these logs every time, like here, for example. Yeah, we see that at 6:44, for example, some message was received by our SF streaming app back container, for example, and you can do any kind of filtering here, and so immediately react to any issues inside your cluster just by getting some timestamp of where an error occurred, filtering on what containers were involved, and just looking at your logs. Next thing I'm going to cover. Of course, if you have any questions or anything else to ask or tell, you don't hesitate to stop me at any time. Then the next thing of how to manage all of your infrastructure is network of the and traffic that goes inside your cluster, outside your cluster, and among the containers inside your cluster. And here, service mesh provider called Istio can help you with traffic management inside your cluster, provide additional things for load balancing, security, and additional layer of observability. And here is explanation why we have deployed the new container, but we still don't see any changes. This is just because we have deployed it in a way that Istio would enable us to run a canary deployment. If you don't know what canary deployment is, it is just the way of releasing your applications when you don't immediately swap the new version of application with the old one, but you just deploy it next to each other, and then you just route some part of traffic into this new version of application. Then you monitor it in real time, check that everything is going okay, and when you are sure that nothing is broken and your users like your new features inside your new version, you just move all the traffic into this new application and switch off the old one. And this is exactly what we are going to do right now with the help of this Istio, which is managing all the traffic for our application. We can observe all our cluster and interconnections in Kiali dashboard, which works on top of this Istio service mesh. And here we can see all the related components to this application that I was showing to you. Yes, it looks quite complex, but imagine how complex it would be to manage if you wouldn't have such an observability tool. And of course, at any time, you can just take some application one by one, like here, for example, and we can immediately see all points which our backend application is interacting with. So here we can see that our backend application is used by front-end application, it is used by Prometheus, and also all the data from our backend application can be sent to Kafka or some other services inside our cluster. And if we go to our front-end destination, we can see that still our version 1 is getting 100% of all the traffic that is reaching our front-end application, which is this one, and our version 2 is getting 0% of traffic. Let me try to change these numbers in real time. So I'm getting that both my new version and old version should get 50% of traffic. And now if I do some updates on our UI, I will see that, okay, now header is still blue. And now I'm getting the gray one just because I'm getting now into this 50% of traffic that should reach this version 2 of application. So, and now the like in 50 of 50 cases, I should get to the gray header of application or into blue one. And when we see that everything works finely, I can, for example, get 0 for our old version and 100% of traffic for our new version of application. I'm just saving that. And now every time I will reload the page, I will get into my version 2 of application, which is remarkable by this gray header. And for example, if at any point in time I see that, okay, something is really going bad and I should roll back, then I just can switch all the traffic to go into our old application version. And now again, I will get only blue one. This is about, like in short, about the service mesh and Istio, and final things about how to maintain your cluster and how it really helps to save costs is, as I've mentioned, that Kubernetes cluster, it automates really a lot of things that usually would require manual processes. And one of them are configuration and secret management, replica sets that ensures that desired number of your containers are always running inside your cluster, and also horizontal pod autoscaling, which will help to scale out or scale in your application based on resources used, and so that your application would always be highly available and performant in a good way. And here we can also do a quick demo. Let me open, for example, compute resources just to get some graphs about our backend application. And we see that CPU usage right now for this backend is really miserable. But we have created the horizontal pod autoscaling, which will scale our application from 1 pod to maximum 5 pods based on our CPU usage, which is now set for 25%, for example. So if this target would get more than 25%, we would add additional instance of our application. And now let me just try to run some load for our application. Yeah, so right now it will just provide some CPU load for our backend application. And we will see that the CPU will start to grow after some time. Meanwhile, just not to wait, I can give the scene back to Juris, and then when he will finish with his slides, we will just get back and we'll see how it's going on with autoscaling. But yes, you can see that right now CPU is already starting to grow.
All right, so it's back to me. Basically, what Alex is showing to you now is that the different support services we would see Siebel working in. So it's going to be like new environment to run Siebel with, I don't know, Kibana, Prometheus, Grafana, Istio, and some other stuff around it. And again, once Siebel officially Oracle releases Siebel Cloud Native Architecture, you can adopt it and see Siebel running just one of the services in your Kubernetes cluster. But like the tooling around will not change. So maybe it's to your question, Victor. Yeah, and also if you go to this site, which is like landscape CNCF.io, you will see plenty of applications and projects which are doing different kind of activities. So you can see that, for example, Istio is in the service mesh, but it's not the only one. It's also the others like Linkerd. Oracle is using for their deployments and stuff Flux, but we like to use Argo. But again, since it is sort of standard protocol and the way how you run things, these different tools could be used interchangeably. And basically the idea is that for every function there are plenty of tools which are available, and then you pick your configuration or whatever your administrators are going to be familiar with. And another comment on these different configuring and interfaces within the tooling around Kubernetes. So when Siebel Cloud Native Architecture will be released, then basic configuration will be provided. So you will have some logs collected through Siebel. You will have some of the routine for deployment your Siebel and setting up like initial instance, some dashboards in Grafana and Kibana, and then you will be able to configure it further to your own needs. So it's not going to be just Siebel, but also basic configuration for the backing or support services around it.
I have stolen back the screen while
all right.
describing that. Yes, I will tell the same as Yuri said, that all this related infrastructure, it will be recommended for use by Siebel. And also they are adopting their Siebel components to be used in this cloud native architectural approach, which will involve all this Prometheus, Kiali, Grafana, and everything that we have shown. And also let me finish this demo case that I was showing, that we can see right now as CPU is growing. Right now, previously it was only one replica of our backend. Right now it has automatically scaled it to 2 replicas, and we can also double check it by checking how many components are there inside our Kubernetes, and we see that, yeah, we have 2 instances of our backend application here. And also CPU, we can see that it's growing on both of instances. Here it's actually after it has launched the second instance of backend, we see that CPU is getting down just because now is load distributed between 2 instances, not just one. This is probably, I can finish my part here and giving then screen back to Yuris.
Sorry, I didn't share the screen previously. But again, if you head to this landscape CNCF IO site, you will be able to see all the different supporting or backing tools which work within this cloud native ecosystem. And again, for your particular case, you can pick either one solution or another, depending on what you're already running or what is your standard tool for deployment, for example, or for service mesh management. But still, since they are pretty much interoperable, it should work also fine with Siebel, or Siebel should work fine with them. Okay, and then why customers should adopt? As kind of mentioned before, first we talk about high availability, scalability. As you saw from Alex's presentation, this architecture is pretty resilient. If in your replica set defined that you should have certain number of pods running in these servers, and for some reason one of them is crashes, Kubernetes automatically will install a new one for you. With this auto scaling, Alex showed that if your load increases, then you can automatically scale up or scale down the amount of resources you need without administrator doing anything. And then with this canary deployment, we can further decrease this, go towards the 0 downtime deployments. So from business point of view, we'll have smaller service windows, we'll have less service outages, and overall Siebel's application will perform much better. But from kind of cost infrastructure point of view, thanks to these auto scaling capabilities, we can always run whatever set of services we need and not more than needed. Like if we don't using QA environment because or UAT environment because our UAT phase is over now, we can just scale it out and wait maybe for another couple of weeks when we will need it, and then automatically build it from scratch in 10 minutes. Simplified operation. So the way how we deploy Siebel, how we get all the different metrics on how Siebel is feeling, it comes in the different dashboards in Grafana, Kibana, or with Istio, Kiali. Yeah. So you will be able to see more stuff there. From Siebel administrator point of view, there is a lot of automation built in so that we don't need to manually respond to Siebel failures or towards deployments and stuff like that. So, and again, we are using standard methods, and as developers, we don't need to find out like special way how we log things, etc. So we can focus on business features development. And again, since the deployment is going to be much safer with lower risk of failure, thanks to automation, we can do it also cheaper with less people involved. Then we can afford to have more frequent releases, and again, which are safe. And to kind of finalize, again, as a next step, watch this recording from Siebel Virtual Clouds. Also in chat window, I kind of put the link, which will get you to Siebel Virtual Summit page. Again, a good thing is to find out whether your organization is already running Kubernetes, and maybe there is like pretty high chance that they are, and you can just kind of hook into that and start learning stuff. So maybe you want to try using Kubernetes yourself, but not on like Siebel critical services, but rather on kind of less business critical ones, at least not touching Siebel initially, so that you learn how it works, you know how to set it up, you know how to operate in this environment. And maybe a good start could be start using Kafka for some of the scenarios. Again, to learn more for what kind of use cases, join our webinar on 18th. And then, whenever you are ready, you can adopt this Siebel Cloud Native Architecture when Siebel releases it next year. Again, we're happy to have like a further discussion with you on that stuff, or if you are like company who is considering it more seriously, again, we can organize sort of private session with you to explain maybe to your colleagues as well. And I think before Christmas, we will get the recording out. So now the first webinar recording is prepared. So you can go to the Idea Portriga site, head to Siebel section and watch a replay of the first webinar. We're going to have webinars also on Wednesday and Friday. It will take us some time to process the video, but I will check once again if we have any questions or chats. No, nothing here. So thanks you very much, and we keep in touch. Have a good evening. Bye-bye.